Hello and welcome to this video on finding the zero of a linear function. So I've put up a video previous to this on the zeros of a function, and if you recall from that, if you've been watching, if not, you can go look at it. If not, don't worry about it. I'm going to redefine a zero here. But remember, a zero of a function is any input that corresponds to an output of zero. So let's take a look at that. I've just got a few examples of linear functions we're going to find the zero of. All right, so my first example is this here. Right? I'm asked to find the zero of the linear function. All right, remember, a linear function takes on that f of x equals mx plus b form, which this has here, where m is 3 and b is negative 15. Right, so when I say zeros, right, the zero to the side here, let's recall that a zero of a function, and again, let's say that function's called lowercase f. It doesn't have to be, but so a zero of a function f is a value, I'm going to call it, say z for 0. It's a value z such that the value of f at z equals 0. So again, like I said earlier, it's out loud, it was any input that yields an output of 0, or any input that corresponds to an output of 0. Okay, so when I'm asked to, for this function here, f of x equals 3x minus 15, so when I'm asked to find the 0, all that means is solve this equation. Solve, f of x, what value of x, what input can I plug in to give me an output of 0? Right? When is f of x equal to 0? When is the output 0? And what is f of x? Well, the value of f at any x is 3 times x minus 15. So this side here is just 3x minus 15, and we're solving this equation. When is 3x minus 15 equal to 0? And I'm just, it's just solving a simple linear equation now. Right, where I would just, I'd first get all the terms with the variable on one side. So 3x I'll leave on the left. We'll add 15 to get rid of that negative 15 there, and do it to both sides. Keep it balanced. We have 3 times x equals, 0 plus 15 is 15. And then to get x alone, I would, multiply both sides by a third, or the same thing as dividing by 3. And that leaves me with the 1x, 3's cancel, leaving 1x on the left equals, 15 divided by 3 is 5 on the right. And there we have it. Right? And of course, as with any equation and solutions to equations, please check, right? Go back in, is 3 times 5 minus 15 equal to 0? Well, yeah, 3 times 5 is 15, minus 15 would be 0. Alright, so the way I would answer this problem, the way I would write this out is, 5 is the 0 of f, or x equals 5. But you could also say that 5 is the 0 of f. You can say it like that in a complete sentence there. All that means is that when I plug 5 in for x in this function f, the output is 0. That's all that means. Great. And it's really that simple. Now you could also look at a graph. I'm not going to do that here, but you could look at a graph of the function I've talked about in previous videos if you want to go look up those, the graph of a linear function. When I say 5 is the 0 of f, that means input at 5, output 0, the ordered pair 5, 0 would be on the graph of the function. That point on the, it would be a point on the x-axis. It would be an x-intercept of the graph of this function. All right. Okay, so let's do it. Just got a couple more. Again, they're really this simple, this quick. So my next one is I have this function called g that's linear, right? It's in that form mx plus b, where m is a half and b is positive 4. G of x equals half x plus 4. So input x, and then over here is how you calculate the output. Right. So I'm again asked to find the 0 of this linear function. So again, all that really means is solve this equation. Sorry, the function is not called f, it is called g. So what g of what x, right? The value of g at what x value, what x input would give me an output of 0. Right. So and what is this g of x? That's, half times x plus 4. When is the output equal to 0? I'm solving for the input. What input gives me an output of 0? And that input would be called a 0 of this function g. Okay, now you could do this a couple ways, right? There's a couple approaches you could take to equations where there's a fraction involved. The way I typically do an equation involving fractions is I find the least common multiple of the denominators of the least common denominator, the LCD, and the only denominator I'm seeing other than 1 is 2. Right? And so we multiply everything by 2 to clear away the fraction. So I take the entire left side and multiply it by 2, and because the entire left side, there's multiple terms here, this will require some distribution. And take the right side and also multiply it by 2. Right. And when you multiply 2 by a half, that gives you 1. Right? The 2's would cancel, leaving me with 1x plus, and then 2 times 4 is 8. And then on the other side, 0 times 2 is still 0. All right. And then finally, get x alone. I would subtract the 8. And the value of x we're looking for, the input that we need to get an output of 0, looks like -8. And again, don't forget to check the solution. Let's see. Plug in -8 for x, right? And half of -8 is -4. And then -4 plus 4 is indeed 0. So this checks out, but we'll check next to it. Great. And that's really it. Now, again, you could have done this another way where I subtracted 4 first and then multiplied both sides by 2 to cancel the half, get rid of the half, make it into 1. And either way, you end up with x equals -8. All right, and again, the way I would word the answer here is, they were asking for, the 0 of this function off to the side here. I'd say, -8 is the 0 of this function g, right, is the 0 of g. That's the number I need to plug in for my input to get an output of 0. Also, too, if you were looking at a graph, as I said in the first one, when you talk about zeros and graphs, it just really is where it really tells you the location of x-intercepts. All right, this is input -8, output 0. So the ordered pair -8, 0 would be plotted on the graph. That -8, 0 would be an x-intercept of the graph of g. All right, again, real simple. Find when you're asked to find zeros of a function, just where is the output? When is the output equal to 0? All right, and then got just one more for you. So here's another function called capital F, and the value of f at input p, right? This time the input's called p instead of x, right? It doesn't really matter what variable, what letter you're using. Still has the same structure. It has that mx plus b, but it's mp plus b, where m is -2/3 and b is +8. F of p equals -2/3 p plus 8. And again, I'm asked to find the 0 of this linear function. So that's basically asking you to solve this equation. When is the output, when is f of p, when is that equal to 0? Right. So we're trying to find p's, values of p that make this true. Well, what is the value, what is the output of this function f at p? It's this negative 2/3 p plus 8. And we're trying to figure out when that is equal to 0 for what value of p. Alright, so same thing, you can do this several ways. Subtract 8 and then multiply by negative 3/2. But again, I'll go through a consistent procedure here. The least common denominator, right, the least common multiple of the denominators, the LCD, is 3 here. That's the only denominator I'm seeing other than 1. So I'm multiplying both sides by 3. Right, so I take the entirety of the left side, negative 2/3 p, plus 8, and the right side as well, and multiply them both by 3 by the LCD. The left side has multiple terms, right? 2 terms, negative 2/3 p and positive 8. So each of those is being multiplied by 3. There's going to be some distributing going on. Now when I multiply the first term, right, you see the 3's canceling. There's 3 in the denominator, 3 in the numerator. Those divide out to be 1. So all I'd be left with is negative 2p. Right? There's only negative 2 and a p left over as factors in that first term. Plus, and then 3 times 8 is 24. Right, and then the other side, 0 times 3 is still just 0. And now it's a nicer looking equation without fractions. All right. Then I would, get all the terms with the variable on one side, terms without the variable on the other. Right? So just take away this 24 term here, subtract 24 from both sides, giving me negative 2p on the left equals negative 24 on the right. And then to get p alone, I would multiply both sides by negative 1/2, or same thing as dividing by negative 2. And we're left with the single p on the left, 1p, right? The negative 2's divide out to be 1. And then a negative divided by a negative is a positive number. And 24 divided by 2 is, this would be positive 12. Right? Don't forget to check, right? Plug in 12 for p. Now 3 goes into 12 4 times, so that'd be negative 2 times 4, or negative 8, and then negative 8 plus 8 is indeed 0. It checks out. Alright, and so that's it. That number 12 is the 0 of this function, capital F. It's the number I can plug in for p to give me an output of 0. And if I were to plot a graph, 12 input, 0 output, out of the point 12 comma 0 would be the now this would be the p-intercept, right, instead of the x-intercept, right? P is replacing x here. It would be the p-intercept of the graph of f, but again, I'm not really doing that in this video. Alright, so again, how I would word the answer here, how I would word what they wanted, it looks to me that 12, the number 12 is the 0 of this function called capital F. And that's it. Again, all that means is when I input 12 to this function f, the output is 0. Wonderful. And again, that's all that and you'll see in future videos, we'll be asked to find zeros of just any old function, not just linear functions. But you're doing the same stuff. When you're asked to find zeros of a function, you're simply finding inputs that give you an output of 0. Alright, great. And I like to say at the end of these, do the best you can to try your best to learn the material, understand the material on your own before you go looking for help. Read the material, of course. Read the author's examples, and perhaps even work on the author's examples before you read how the author did it. And then check your work against the authors and see if you can learn from mistakes there. And practice problems, exercises, check answers when they're made available to check yourself, keep track of your progress. And don't just give up after the first attempt. Don't be so easily frustrated. But if after several approaches to a problem, several attempts, you're still not getting it, it's still not clicking, maybe you should go back and read the material again, more slowly and deliberately, take notes. Maybe even a third time, because who knows, maybe that second or third read through of the material will shed some light on things that you didn't see the first time. Or maybe after working on some problems and then reading the material again, you'll have a clearer idea as to what's going on in the exercises. But if after several read-throughs of the material and several approaches at problems, you're still not getting it, then it's not a sign of weakness whatsoever to ask for help. That is what other people are there for. Ask a teacher, a tutor, a friend, someone else in the class who you know knows the material well and is willing to help. Try to find supplemental materials online. There is loads of stuff out there. It's very easy to search for, I promise you. Try to find videos on the subject, videos maybe like this one, or and I assure you about this too, there are definitely plenty of videos out there on these topics, these math topics, that are better than mine, and they're very easily found as well. But just keep at it. Don't give up. Stay persistent. Keep practicing. And also try to have a positive attitude. I find that can make a lot of difference. Instead of constantly saying you hate math, you've always hated math, it never came easy. Well, you're probably going to continue to hate it if you keep thinking that. So try to go in with an open mind. Try to go in thinking, I'm going to enjoy this. I'm going to pull something from this. I'm going to take something out of this. I'm going to learn something and enjoy learning it. I'm going to have a positive attitude, but maybe even have some fun. And it is amazing the difference just a change in attitude can have towards a subject, for the learning process. And so just stay persistent, keep practicing, try to keep a positive attitude, don't give up, and I'm sure you'll get it. I know you'll get it. I believe in you. And thank you for watching.